So last class we had already discussed how we will dissect out the prox sciatic nerve and the gastrocnemius muscle preparation. Today we will discuss how we will take the recording and how we will study the properties of the muscle by this experiment. So first you will talk about what is the aim of the experiment. Now the aim of the experiment is to record a simple muscle contraction. Now this experiment is done on the principle that when an adequate stimulus is applied to a muscle, there occurs a sharp contraction followed by a quick relaxation. This is known as a simple muscle twitch. The recording of the simple muscle twitch is known as the simple muscle curve. A time tracing taken below this curve helps us in calculating the various phases of the simple muscle twitch. So how is it done? Okay. So how we will record the contraction of the muscle. Now for that, you already know, last class we have already told you that if this is the muscle, if this is the tendon, this being the sciatic nerve and this is the vertebral column, we will attach the tendon to the hook of the isotonic lever that is present in the MyRub board. Next, we will see the electrodes which are coming from the secondary coil of the Du Bois-Reymond induction coil is turned over the nerve because these will give the stimulus. Okay. So once it is arranged, once this part is arranged, once this is arranged, now you know from your theory class that whenever we will give an adequate stimulus, there is a contraction of the muscle. That is what we will record. Now before we start the experiment, before we start it, we have to know that the drum speed during this recording is 640 meter per second. So okay, we put it at 640 meter per second and we will start the drum. Okay. Now before we take the recording, first of all, we have to bring the lever just so that it touches the drum, and we move the drum once so that it takes a baseline. Okay, so in your drum, first we will take a baseline. Okay, now once the baseline is taken, next our aim is to record what will happen when the muscle will contract. Now before we give the stimulus, if you see, suppose if current passes through the sciatic nerve, you will see once this nerve is stimulated, there will be contraction of this muscle, and you see if there is contraction, that means the muscle will shorten, and you see the liver is moving up, the liver is moving up, and whenever it relaxes, the liver will move down. Therefore, contraction will be recorded as an upstroke and the relaxation will be recorded as downstroke. Now you see, once the whole primary circuit is being made, how do we go about it? After we record the baseline, next what we do, we turn on the drum and at one point we suddenly put on the switch. As soon as we put on the switch, what happens? A current starts passing through this primary coil and an induced current is formed in the secondary coil. That induced current is transmitted to the nerve, the sciatic nerve, and the muscle will contract once and it will relax. So we will just put on the switch once and switch it off. So what will be your recording? As I have already told you, the contraction is upstroke. So you will find that you get a recording, there will be upstroke with the contraction and a downstroke with the relaxation. Now here, if you see the diagram, I told you contraction is upstroke and the relaxation is downstroke, but we do not get the curve like this. We get it like a hill-like manner. Now this shape of the curve is got because of the speed of the drum. Okay. Now once we get this curve, this is the actual recording. So the point where the contraction has started, this is known as the point of contraction. The height, the greatest or the maximum height that is reached by the contraction, this is known as the height of contraction. And the end where it has touches against the baseline, this is the end of point of relaxation or the end of relaxation. Okay. Now this is the curve that is got. Now here, after recording this curve, our aim is to record where actually the current has passed through the muscle. That means we have to record the point of stimulus. That means the time, the exact time at which the current has passed through the nerve. Now how will we record it? After this is completed, after you have recorded the curve, what we do, we do not pass any current. What we do, we lift up this lever and you see there is a striker here. You have to know that whenever the striker touches this contact knob, that is the point when the circuit becomes complete and the current passes through the secondary coil. So what we do, if wherever may be the lever, we just try to bring it back to the contact point. Once we bring it back to the contact point, we mark that point with the isotonic lever. Okay, the marker of the isotonic lever. So that point when it was touching, that was the actual point when the current has passed. Now on the curve, you will find that point, the point of stimulus, that is where it has passed, which is known as, now here I have written it as PS. This point of stimulus is never same or similar to the point of contraction. That means there is some time interval between the application of the stimulus and between the actual start of contraction. This period between the point of stimulus and point of contraction, this period is known as the latent period. Okay, this is known as latent. So you see, the point of stimulus is never similar to the point of contraction, and that time is known as the latent period. Now what are the causes for this latent period, or why do we see that the point of stimulus is never similar to the point of contraction? Now latent period is because of basically 5 causes. Now the first is some time will be required for the impulse to pass through the sciatic nerve. Next is that some time will also be required for the impulse to travel across the neuromuscular junction. The third is some time is also required for the excitation, contraction, coupling of the muscle. The fourth is some time is also required to overcome the inertia of the liver. And also to overcome the viscosity of the muscle, some time is required. Now because of these reasons, there is a gap between the point of stimulus and the actual point of contraction, which is called the latent period. Now in frog, this latent period is around 10 milliseconds. Okay. Now the next phase of this curve is the contraction phase. Now the contraction phase is from the point of contraction to the height of contraction. The height of contraction means the point where there was maximum contraction. So this is the contraction phase. And the relaxation phase is from the height of contraction to the end of relaxation. So this part is the relaxation phase. Now how will we know what is the duration of each curve? For that, we have to take a time tracing below this curve. Now the time tracing is taken with a time tracer. Now this is a tuning fork of 100 Hertz. You will see there is a pointer which is attached to it. Okay. Now 100 Hertz means 100 cycles per second. So how do we do it? Okay. How do we record it? What we do, we remove this isotonic lever and we start the drum. Now when we start the drum, we just hit the tuning fork, take the recording, and strike the tuning fork or the time tracer, and we just touch it on the drum. Okay. So when we stop it, you will find that there are areas where there are certain troughs and certain crests. So that is how we take the time tracing. So below the curve, we take the time tracing. Now since the frequency of the tuning fork, I told you, is 100 Hertz, that means 100 cycles per second. So each trough will represent your 0.1 millisecond. Okay. So from this time tracer, we can calculate the duration of the contraction period as well as the duration of the relaxation period. Now for a frog's sciatic gastrocnemius muscle preparation, the contraction period is around 40 milliseconds and the relaxation period is around your 50 milliseconds. So if you can see in the diagram also, you see the contraction period duration is less as compared to the relaxation phase. Now coming to a part of the curve, which you will see I have drawn a curve after the end of relaxation. This part of the curve is known as the physiological curve. Okay, it's known as the physiological curve. Now why do we get this physiological curve? Now this physiological curve is got because of the inertia of the whole liver and the drum. Okay, so because of that inertia, we get a curve even after the end of relaxation, which is known as the physiological curve. Now you see, I told you the latent period is 10 milliseconds, the contraction phase is 40 milliseconds, and the relaxation period is 50 milliseconds. Therefore, for a frog's simple muscle contraction, the total time taken is your 100 milliseconds. Okay, it is 100 milliseconds. But for human beings, this time is only 30 milliseconds. So these are the different phases of your simple muscle curve. Now in your exam, this curve will be shown to you. So if you can see in this curve, the point where it is written A, this is the point of stimulus. Okay. Now you see there is a point which is written as B. This point is the point from where the contraction phase has just started, and this is the point of contraction. So the gap between A and B, that gap is the latent period. Next you see there is a point where it is written C, which is the height of contraction. So the period between B and C is your contraction phase. Okay, it is the contraction phase. Then there is a point where there is the end of this relaxation, where it is D is written. So the phase between C and D is your relaxation phase, and this part of the curve is your physiological curve. Now this is the time tracing that has been taken below the curve. Now if you can see from this curve, the time tracing, the time between A and B, if you see here below, there is just one crest. Okay, so that means it is 10 milliseconds. Now if you see between B and C, if you see the number of crests is 1, 2, 3 and 4, that means the contraction phase is your 40 milliseconds. Next you see between C and D, the phase is 1, 2, 3, 4, 5 and 6, that means it is 60 milliseconds. So this is the this is known as the recording of this simple muscle twitch, which is known as simple muscle curve. This, since it is recorded in a myograph, this is known as myogram. So when this will be given in your exam, you have to say that this is a myogram showing the effect of a single adequate stimulus on the frog's sciatic nerve gastrocnemius muscle preparation. So once you say that, your whole answer is complete. Thank you.